So what does it say? I did not present it. Of course, it's not going to be on the test. I did not present it. This is something just for your information. Here's the reason why I did not present it. It's not part of algebra. It's part of calculus. That's one reason. The second reason is, in order to understand intermediate value theorem, we have to talk about continuous functions. We have to talk about continuous functions first. And then continuous intermediate value theorem applies only to continuous functions. Again, continuous functions is a topic from calculus, not from algebra. But since Heather asked, and she has all the right to ask, because there is one problem, or maybe two, in my math lab, I'm going to explain what continuous functions are. Continuous functions, or a function is continuous only when I graph it without raising the pencil off the paper. I'm done. This is a continuous function. This is a continuous function. Both continuous. But this one, look what happens. This is not a continuous function. It has a jump. Here's another function that is not continuous. Here's another example. And here's a third one. How is this line called? Vertical asymptote. This is called infinite discontinuity, and this is called removable discontinuity. So this is a jump discontinuity. The second one is a removable discontinuity, and the last one is called infinite discontinuity because it has a vertical asymptote, or because it goes to infinities, even better. So this theorem applies only to functions like these, not functions like these, which are not continuous. Okay, so what does the theorem say? The theorem says that if we have a continuous function on an interval a comma b, this is the interval a comma b, whatever you want, it doesn't matter, and let's suppose the function does this, going from negative values to positive values. The other option would be, if the function is continuous between a and b, it could do this, coming from positive values and going to negative values. So, the intermediate value theorem is valid only for continuous functions, and only if, on a certain interval, it changes sign. Because if the function is continuous and it changes sign, it has to cross the x-axis, if it's continuous. If it's coming from negative, it cannot jump over 0 and go positive. Or if it's coming from positive, it cannot jump over 0 and go negative. So the intermediate value theorem says, number one, the function is continuous on the interval a comma b, and it changes sign, either this way or this way. Therefore, there must be a solution between a and b. There must be an x-intercept, c. There must be an x-intercept there where f of c is 0. What the theorem does not tell us, it does not tell us what it is. It cannot tell us what it is. It only says, look, if you're looking for an x-intercept or a 0 or a solution of f of x equals 0, and the function is continuous, and it changes sign between 1 and 2, the solution is somewhere between 1 and 2. But it doesn't tell us what it is. That's the intermediate value theorem. So the following conditions. So number one, f continuous on a comma b, and number two, f of a positive and f of b negative, or f of a negative and f of b positive. It means from these two, the result is that there exists C in the interval open, not closed, A comma B, such that what? F of C is exactly. We don't know what it is, but we know it's between A and B. That's the intermediate value theorem. I did not present it before. Not part of algebra. Because there is a big theory behind a continuous function. There is a theory about the function being continuous at the point. So that's why I didn't. Perfect question. Anything else? Yeah. Please. Only for you. Just kidding. Just kidding. Number 10. Let's look at number 10, number 10, number 10. Very good. So in number 10, we have f of x, negative 0.1 x squared plus 0.6 x and plus 5. We're asked to find the maximum height and where it occurs and where the ball hits the ground. Or for you, where the ball hits the ground. Okay, so what is the starting point? What do I have to do first? Yes? Alex, go ahead if you want to say something. Yes. How? Perfect. Yes. How?
Negative leading coefficient, so it's going to be a maximum.
Yes, so this gives a maximum. Very good, because the leading coefficient is negative 0.1. Great job. Good. How do I find it?
Quadratic Formula.
Vertex B.
Yes. The vertex is the point that will give us the maximum. Very good. So for the vertex, how do I find the x coordinate? Because I can't find the y coordinate before I find the x coordinate.
Negative B over 2.
Very good. The x coordinate is negative b over 2a. Negative in front. B is 0.6. 2 times a is negative 0.2. So remember, this is the time. Say it again.
I don't get that whole thing.
These are the coordinates of the vertex. Right? The coordinates of the vertex. So what is the answer? And remember, we're talking about distance here, so it cannot be negative, right? So it is 3. So if the x coordinate is 3, is that clear, Alex?
Yes, I know I got that part, but vertex.
You have to remember it. Yep. It's negative b over 2a. Yep. I mean, I can prove to you why is it negative b over 2a, but it will take about 5 minutes. So this is the distance in feet. How do we determine the maximum height now?
Again, 3.
Very good. So we have f of 3, negative 0.1 multiplied by 9, plus 3 times 0.6, 1.8, plus 5. Any questions? Dylan, any questions? Ariel, any questions? Are we following? Can you follow? Perfect. So negative 0.1 times 9 is negative 0.9 plus 1.8 is 0.9. 0.9 plus 5, I think, is 5.9. Correct me if I'm wrong, anytime. I'm not making mistakes intentionally to see whether you are awake or not, but they may happen, so please point that out to me. So we determine the vertex, which tells us what?
That the maximum height is 5.9.
Yes, so we can already start graphing this function, getting it ready. We know that when x is 0, which is the y-intercept, y is 5. So 1, 2, 3, 4, 5, and 6. And this is 5.9 at 3. 1, 2, 3, at 3, 5.9. And it starts here. So I already have 2 points for this function. And this is definitely the axis of symmetry, x equals 3. So this is what I know so far. And then I'm asked to find when does it hit the ground. How do I determine that? What do you think? How do I determine when it hits the ground? Yes, I need to find the x-intercept. So I set f of x equal to 0, which is negative 0.1 x squared plus 0.6 x plus 5 equals 0. How do I solve this equation? And first of all, what type is it?
Quadratic.
Excellent, quadratic. What do you have to do first? I shouldn't say have. What I would recommend do first. Yes, multiply both sides by negative 10, get rid of the decimal numbers, and get rid of the negative leading coefficient. So this is x squared minus 6x minus 5 equals 0. Of course, what I forgot, something very important. I cannot just pick and choose. I multiply the first term by negative 10, the second term by negative 10, and of course the last term by negative 10, as well as 0 by negative 10. So now I have everything I need to use the quadratic formula. Negative b plus or minus b squared, minus with a minus, positive 4ac, that's 200 over 2a. Yes, I will have to approximate. Let's approximate with a graphing calculator. If you have the answer, let me know. I'm looking for my calculator here. Here it is. So when you put in the graphing calculator, be very careful to put parentheses around the numerator. You know me, I will always put parentheses inside the square root as well. So left parenthesis, 6 plus the square root. The more sophisticated calculators will not require parentheses under the square root, but so this is 236. Close the parenthesis, outside, close, and divide by 2. The other solution will be with a negative. I will override the positive. It's easier with a calculator than with this software. So negative 4.6, negative 4.7, I would say. So x equals negative 4.7 feet, unacceptable, and x equals 10.7 feet. So here's what I do. So this is 3, 4, 5, 6, 7, 8, 9, 10, 11. And then on the other side, 3, 4, 5, so negative 4.7, 4, 7. Okay, so this is not required. It's behind the launching point. So here it is, reaching a maximum and then hitting the ground exactly at 10.7 feet. This point is the vertex, and the coordinates are 3, 5.9. And the solutions, of course, this is unacceptable, but it's there. Mathematically, it's correct, but we cannot consider the distance that is negative. Do we understand each step of this problem? Any questions here? Please ask. Any questions? Any questions? Yes, please.
So the maximum height is 5,
0.9.
5.9.
Correct.
Why didn't you write it to 6?
I didn't.
No, I'm saying why didn't you?
The direction.
Because-
For the nearest town.
Yeah, so the nearest 10th. So I would not run 5.7 to 6. Now, if I get 5.7 people, I will not round it up ever. I will say 5, because the 0.7 does not mean another person, right? So it depends. In this case, 5.7, I will keep it as 5.7. Good. Next question. Anything else you would like to go back to? Anything? Which one? Yes. Yes. Is that a good? Say it again. Number 5? Yes, let's do number 5. So in number 5, we have a function that is 7x minus 1. And we're asked to find f inverse. And then graph both, and then use interval notation to present the domain and range. Excellent. Perfect question. Okay, so first of all, I'm going to ask you, what type of function is it? Because obviously the next question would be if it's one-to-one.
Linear.
Yes. It is linear. Awesome. Is it one-to-one?
Yes.
Yes. By the?
Vertical.
No.
Horizontal.
By the horizontal line test. Very good. That is a one-to-one function. Great job. Now, can anyone identify the domain of function f and the range of function f? Remember, right, negative infinity to infinity. And the range?
Infinity. Negative 3 to 6.
Correct, because we already picture in our heads with our mind's eyes, right? We already picture the graph. Perfect, excellent. So now I want to determine its inverse function. What would be the first step?
Replace
Yes?
x with y. Oh, minus y.
First step?
Change it for this.
Yes. So y equals 7x minus 1. Step 2, correct interchange. And now I'm solving for, very good, for y. It's already solved for x, right? We're solving for y. So x plus 1 equals 7y. And how much is y? Yes, so you can write it as 1/7 x plus 1/7. You can write it as x plus 1 over 7. It doesn't matter. But you have to replace it by this. Whichever form you prefer. But at the end, this is f inverse. Now what?
You check if it's x. If it equals x.
We don't have to. It doesn't ask us to do that. If you want, you can, just to make sure. But I don't recommend spending your time on checking unless you are asked to. You can go back at the end of the test, if you still have time, and go back and do that. So you can check. But I don't recommend it. Just stop what you're doing instead of making progress throughout the test, and do something that it's not required. If you have time, come back at the end and say, let me check that. You can make a little star and say, I'm coming back here to check. But in this problem, we're not asked to. It says find f inverse, which we did, graph them on the same coordinate system, and then use interval notation to give the domain and range for this. We already did. Because we wrote the domain of the function and the range of the function, what will be the domain and range? I still see cell phones, although I kindly asked you to put them away. It doesn't matter.
Infinity to infinity.
Yes. So indeed. So the domain of f inverse and the range of f inverse are just the reverse of these two, but when you reverse them, you still get the same thing. Okay. So next we have to graph them on the same coordinate system. So let's do that. Good. So let's start with 7x minus 1 was our original function. So we have f of x, 7x minus 1. When x is 0, how much is y? -1, very good. Y equals -1. So 0 comma -1. And now when y is 0, we move 1 to the other side and we get 1/7. So we have 1 over 7 comma 0. So this is the y-intercept, this is the x-intercept. And if you ask me how we are going to plot 1/7, I'll say with difficulty. Okay, so if this is 1, bless you, and this will be 1/7. You're going to dispute that, and I will have to agree with you. It's very disputable. It's not really 1/7. And then 0, -1 is this point. So I'm going to graph the function. So this is f of x, 7x minus 1. Very good. So now please give me 2 ordered pairs. Do not forget to graph this very important line, which is y equals x. Whenever you're asked to graph both the function and the inverse on the same coordinate system, you have to graph y equals x. It's a must. So can anyone give us 2 ordered pairs that will help us graph the inverse function?
0.
Say it again.
0.
You said 0, 1/7? I completely agree. Indeed, 0, 1/7. Great job. Good. Another one. -1, 0. Great job. So here's the graph. And obviously this point. Here's the graph of f inverse, which is x plus 1/7. Well done. Any questions?
What are the 3 points on that image?
Say it again.
What are the 3 points on that image?
As we know, if the function goes from 1 to 2, the inverse function goes from 2 to 1. So our function here went from 0 to -1. Of course, -1, 0 will be the second point, the reverse point. This one was 1/7, so then I need 0, 1/7. And this point is mandatory. If the blue function crosses the y equals x at this point, that point is 1, 1, 2, 2, 3, 3, 4, 4. Reverse that, it has to be part of the inverse function as well. Is that clear? Yes, everyone? Yes, Alex?
How you got the points for
The x and y intercepts of a linear function. I make x equals 0, I determine y. I make y equals 0, I determine x. Right? So when x is 0, I plug in, I get -1. 0, -1. Then when y is 0, I have 0 equals 7x minus 1. I move 1 and divide by 7. Very good. X-intercepts are actually the same for any function. Good. Next question. Number?
3 and 4.
Yes. Let's go to 3 and 4. Any questions on this? Or we move on to 3. Okay. So 3, we are given f of x equal to x minus 5 and g of x equals x squared minus 5. We are asked to find f. Any questions? Dylan, any questions? Ariel, any questions?
I just don't get it at all.
Which part? The previous one? You're talking about the previous one? Or just this one?
This one.
Okay, yeah. Okay, sure. I haven't even copied it yet. Just give me 1 second if you like. And then f come g of 0. And then g come f of 0. Good. So here we have 4 questions. So first question is asking us to find f come g. Anyone remembers the definition of f come g? How do we start f come g?
with G of x except
So you mean
F and
of,
then G
let's say it, f
of
of g of x. That's it. Perfect. Can anyone tell us the next step? Yes, Vinny, go ahead.
Isn't it supposed to be 3x squared minus 5 for g of x?
I copied something else. I'm very good at that. So 3x squared. Yes, yeah. My mistake. Thank you. My apologies. Okay, so f of g of x. What would be the next step? Anyone?
F of 3x squared.
So I have to write f of 3x squared minus 5. Great job. Next step.
You pop minus 5 at the end.
So what will you tell me? Just dictate and I'll write it.
Parentheses 3x squared minus 5 parentheses minus 5.
Very good. So all we have to do is just write 3x squared minus 10. Is this okay, everyone?
Not the same thing.
Is this okay? Ariel, is this okay? I'll be more than happy to answer if you have any question, anything.
Oh wait, never mind. I get it. Yep.
Okay. So now since we are here and we're asked to find f comma g of 0, let's find it. What is it? Negative 10. We have the function. We don't start from scratch. There is no need. We have the function. We just replace in the function. We have f comma g of x. We have it. So now I replace 0 and I get negative 10. So let's determine g comma f now. You can go back, but you're going to be working harder. We already put the time in to find the function, and I'm asked, that's why I stop for a moment, not have to go back. So I have the function, and now I can find f comma g of 0, or f comma g of anything. Can anyone give us a definition of g comma f?
G x
Of, I want to see hear the of.
G of f.
Thank you. That's it. Of f of x. Great job. So then g of,
Negative, x negative.
very good. Awesome. Great job so far. Perfect. Next step.
And
Yes, 3.
Excellent.
Excellent. In parentheses. Good. Excellent. So now let's expand. We have to expand.
3.
Okay, so it's x. Anyone but Heather. I want to hear anyone but Heather. You're punished. X squared. Excellent. Thank you very much. You made me very happy. So this is 3x squared minus 30x, and that's 75 minus 5. It's 70. Minus, because it's minus. Good. So now we are asked to find the g comma f of 0. I have the function. How much is g comma f of 0? 70. Well done. Any questions on this? Anything? Any questions before we move on to number 4? Any questions? Okay, let's look at number 4. Is this better? Yes?
Yeah.
Very good. So number 4, we have age of x equals the 6th root of x to the 7 minus 4. Minus 4, right? Yes. So they want us to find an inner function, and we should call it g of x, and an outer, and we should call it f of x. Can anyone give us an idea about the inner and the outer?
6x.
Which one? We cannot start with the 7th root. We have to start by evaluating this piece. And when I'm done and I get one number, that's when I apply the 6th root. I cannot start with the 6th root if I don't have a number here. So the inner function must be x to the 7th minus 4. When I get one number, then the next one will be the 6th root of x. Do you understand? It's the order of operations. So if you are asked to evaluate this function, you will evaluate what's under the root first and then apply the 6th root. Would you agree? Yes? So the inner function must be x to the 7th minus 4, and the outer function must be the 6th root of x. Next question.
You do number 9.
Number 9. Very good. So this is the equation of the circle. So the equation of the circle is x minus h squared plus y minus k squared equals r squared. Any questions, ladies?
What number is it?
What number is this?
It's number 9.
Number 9.
Brian, did you say 9?
I did.
Yes, just making sure. Okay, so we have the center, which is negative 3, 4, and we have the radius, which is 5. All we have to do is just plug it in. X plus 3 everything squared plus y minus 4 everything squared equals 25. In case we're asked to graph, then we will graph. Yes, please.
So whenever they ask for the standard form of the equation of a circle, that's what that is.
Yes, there is no other equation of a circle. This is the only one.
What do they ask us to graph it? Can you like show us how now?
How to graph it?
Yeah.
Of course. Of course. So we graph negative 3, comma 4. And the radius is 5. So this is 3 units, I need 2 more. 1, 2, 3, 4, 5. This is 4 units, I need 1. 1, 2, 3, 4, 5. Okay, so what I did not get the chance to is to go through this from last time, just real quick. We know there are 3 types of rational functions. I did not present the third one, and the reason was the third one was removed from our pre-calculus classes, so I thought that it's beyond the scope of this course, and also the book does not have any applications, so that's why I did not show you type 3. If you found type 3 in your homework, I'll be more than happy to show you. Okay, very good. So we have to go through all these steps when we graph a rational function. So these were some examples that we looked at of type 1 and type 2, and one with a hole in the graph. And then we look at the last section, polynomial and rational inequalities. So we use the table to study the sign and answer the question. Remember, the table helps only if we have a ratio or product ratio of factors or product of factors on one side and 0 on the other. Otherwise, the table does not mean anything. It's not helping. So here is another example. Okay, so back to your questions. Anything you'd like to look at?
Number 12.
Number 12 it is. Here it is. So in number 12, we are given a function, which is f of x, negative x to the 4th plus 25x squared. In this function, in this problem, we are asked to graph and present everything possible, anything that we need to know about this function, anything that we studied about it. And there's a lot. First, the degree.
It's 4.
The degree is indeed 4. Very good. How many solutions or x-intercepts? 4. How many numbers, what is the maximum possible number of turns? 3 turns. Max possible 3 turns. It doesn't have to turn 3 times, but it cannot turn more than 3 times. Okay, so then I will, and the domain, by the way.
Negative.
Correct. All polynomial functions are friendly. So now when I find the x-intercept, meaning I have to set y equal to 0, I have negative x to the 4th plus 25x squared equals 0. Like always, we will have to multiply or divide by negative 1, and we get x to the 4th minus 25x squared equals 0. And we will factor out x squared and get this, and continue factoring into x plus 5, x minus 5. And when you're ready, please give me 4 solutions. Twice. So x equals 0 twice, multiplicity 2, which means turn. So 0, comma 0, turn.
X plus 5.
Indeed, very good. X equals 5 and x equals negative 5. And this is just a cross. Simply because this is multiplicity 1 and multiplicity 1. Now the end behavior, hold your thought. So the end behavior, remember this is degree 4. It behaves similarly to, or similar to what? X squared. Quadratic, perfect. So the leading coefficient is negative. So is it going to be this end behavior or this end behavior? Very good, awesome. Yes, Nadia, go ahead.
So if the multiplicity is odd, it's a cross.
Correct.
If it's positive, if it's even, it's a term.
Correct. Very good. So that's all we need except symmetry. So what is f of negative x? It's negative x to the 4th plus 25 negative x squared. So this is negative x to the 4th plus 25x squared. It's the same and identical with the function. What does that mean? When f of x is identical with the function is even, symmetric with respect to the y-axis. Very good. So even, symmetric with respect to the y-axis. That's nice to know. Why? I'm going to graph the left-hand side and just copy on the right. I'm not going to graph the whole thing. So that's all I need. I just need a table. Negative 5, 0, 0. It's coming from negative infinity, crossing normally at negative 5. It must have a turn because it comes back to turn here. Now I don't care about the rest. I know the function is symmetric with respect to the y-axis. I have to make sure I graph it as symmetric as possible. My graph is not symmetric. It's not perfect, far from being perfect. Of course, the units are not perfect. So, but that's the graph of x, negative x to the 4th plus 25x squared. And what I need now is determine the max. And we can do that by hand. So with the graphing calculator, in y equals, please put it in, s negative x to the 4th, and then plus 25x squared. I don't know how high the viewing window should be. I'm going to mess with it a little bit. So I'm going to say between negative 6 and 6, that's good enough. I have a cheat here, so something that's huge, as you see in the positive side. So y minimum, I don't really care for more than negative 2. But for y maximum, I don't know. It can be 100 with a scale of 10. I have no idea. It's a trial and error here. Not good enough. I can see the maximum to determine it. So I'm going to go back to the viewing window. I'm going to change this to 200 for the y maximum and with a scale of 20. Let's see now. That's good. I know the maximum is between -5 and 0. I go with second and calc. I want the maximum, which is number 4. The left bound is -5. The right bound is 0. And -3.54. -3.54. You don't have to adjust your graph or anything. 156.25. So if we have the left maximum at -3.54, comma 156.25, can anyone give us the maximum on the other side? Very good. 156.25. Yes, please.
How do you find the maximum minimum calculator?
Yes, let's do that again. So after I put the function in, then I go with second and calc. A menu pops up, and I choose 4. Is that okay so far? Okay, once you choose 4, the calculator doesn't know what you want. So you have to give it a territory. It's asking you for a left bound and a right bound. Since I'm looking for that, I'm going to give -5 and 0. So -5, enter, 0, enter. And so -5, enter, 0, enter. And you see 2 vertical asymptotes, if you want, pop up. One at -5, where I chose to be my left bound, and one at 0, where I chose to have the right bound. And now I don't want to guess. You can put in -4 or -2 if you want to, but I don't like to do that. I just press enter again. So it gives us the maximum. Is that okay?
Yep.
Very good. Other questions here on this problem? Anything else? Okay, let's go back to your questions. Anything? Number 13? Number 13. Where are you, 13? Yes. We looked at this function together in class. It's coming from one of the sections. So it's 3.2.5. So we're given a function. It models the pH level of a mouth X minutes after eating food containing sugar. The graph is given. And it says, what was the pH level after 36 minutes? So after 36 minutes, it's hard for me to read from here. I'm going to say possibly 4.8 or 4.7. After eating sugar, when is the pH level the lowest? Again, I'm assuming maybe here, 24 minutes, at 4.5. Part C, the normal pH level is? Yeah, very good. Part D, what is the equation of the horizontal asymptote? Right, because it's the same degree over same degree, it's type 1, leading coefficient over the leading coefficient. Very good. So what does it mean? What was the other? Okay. What does this mean in terms of the mouth pH level over time? The mouth pH level over time increases without bound. Absolutely not. Over time gets progressively further from the horizontal asymptote. Absolutely not. The mouth pH level over time decreases without bound. Absolutely not. pH level over time gets progressively closer to the horizontal asymptote. Yes. Use the graph to describe what happens to the pH level during the first hour. Starts at 6.5, decreases rapidly for 24 minutes. For the remainder of the hour, the pH level gradually increases back towards 6.5. Correct, but I have to read the other two as well. Starts at 24, absolutely not. pH level starts at 4, absolutely not. So it's part A. Very good. Next question. Number 10? Which one? Number 11. Let's look at number 11. Which one? There was something else? Okay, number 11. We just, no, 10. Okay, sorry. So you're not going to be asked to look at the synthetic division, of course. We did not present synthetic division. I'm going to ask you to use long division. So you still want to do this with using long division, correct? Okay, very good. So first of all, what is the degree of the top? So this is problem 11 on page 3. Problem 11 on page 3. Say it again. Degree 5, very good. So degree 5 is there. Degree 4 is missing. So plus 10 to the x to the third. Degree 2, degree 1, and negative 11. And we are dividing by x minus 1. Good. First step, please. First step.
What times x?
Exactly. So what times x is x to the fourth? I'm sorry. What times x is x to the fifth? Of course, my mind, I'm sorry. So we go back, negative x to the fourth times, x to the fourth times x is x to the fifth, we subtract. Negative x to the fourth plus x to the fourth. Bring down the next in line. Yes?
Is that negative x to the 2 plus x to the 4? Because it looks like a 3.
Yeah.
Okay.
Next question. How do we continue?
X to the
Yes. And the sign. I need the sign though. Very good. Plus x to the third. Positive x to the fourth, negative x to the fourth, negative x cubed, positive x cubed. So now 11x cubed. Good. Next question. What is the next step?
11x squared.
Very good. Awesome. Plus 11x squared. Great job. Positive 11x cubed, subtract. Negative 11x squared, subtract. Very good. Awesome. Very good. Next step.
Plus 11x.
Very good. Plus 11x. Excellent. Positive 11x squared, subtract. Negative 11x, subtract. When we subtract a positive, we get a negative. When we subtract a negative, we get a positive. So 11x minus 11. Final question. X times what is 11x?
11.
Positive 11. Very good. Positive 11x subtract. You know me, I always run out of room. So it's negative 11x. And negative 11x, negative 11 plus 11, at least that, no remainder. So from here we have x to the fifth plus 10x cubed minus 11 over x minus 1. Can anyone give us the answer? It is x to the fourth plus x cubed plus 11x squared plus 11x plus 11, and no remainder. And I have a question for you. Is x minus 1 a factor?
Yes.
That does it. X to the fifth plus 10x cubed minus 11. So according to Z, it's yes. Can anyone tell us why she said that? And you can say, how do I know? No, you do know.
Is it,
So why is it a factor?
is it because there's no remainder?
Perfect. That's the answer. There is no remainder, there must be a factor of the top. Absolutely. Very good. Say it again. Next question, please.
You do 14.
Yes. Let's look at 14. Very good. 14 is probably the last one, isn't it? Yes. So here we have a what type of inequality? Very good. So we have x plus 7, x minus 9, and x plus 5 less than or equal to 0. It is a rational inequality. Is it ready for a table?
Yeah.
Yes.
It is ready for a table. Because it's already in a product form or a ratio form. So we don't have to do anything. We just have to list those. And list the ratio as the last item. X is the variable in the problem.
Minus 5.
So in order from left to right, the numbers in the table will be very good. Next one, -5, and the last one, very good. Do we all agree with -7, -5, and 9? Yes? Okay, so there is a 0 for x plus 7 where?
-7.
Good. And 1 for x minus 9? Very good. And 1 for x plus 5? Good. What happens to the ratio? Let's think for a moment. What happens to the ratio?
Oh, came 0.
So what happens when x is -7? 0. What happens when x is -5? What happens when x is 9? Very good. As you see, there is no discussion here. These are polynomial functions, linear functions. They all start in the same way. They go in the same direction. So all you have to do is copy the signs, as we know. The first subinterval, we are multiplying 3 negatives. The next subinterval, we multiply or divide. It doesn't matter. Same thing when it comes to the sign. It's not the same thing if we multiply or divide, but the same thing when it comes to the sign. Positive. Next subinterval. And the last one, positive. And now please tell me, what will you pick? Because you can only pick one or the other.
-7.
So which sign are we picking?
-7.
Very good, indeed. Perfect, yes. Infinity, -7, and -5 and 9. Good. Remember the equal symbol is there. I cannot include -5, but I have to include -7 and +9. So the final answer is x in the interval -∞ and -7 with a bracket, but -5 with a parenthesis and 9 with a bracket.
Can you real quickly go over like all the things? These transformation signs.
What do you mean by transformation signs?
It's like if you like what makes it graph go like left or right, up or down.
So first of all, if we subtract from x, if it's x originally x minus 5, we go to the right. If it's x and x plus 4, we go to the left. And if we have y multiplied by a negative number, then we reflect with respect to the x-axis.
So
Positive y, negative y, or negative y, positive y. I'm not sure whether this is what you expected. So did I understand your question correctly?
Yeah, kinda.
Okay. Correct me if I didn't answer fully.
No, it's just I don't understand the whole the shrinking and stretching. That's the problem I have.
Is it the horizontal one or the vertical one? Because they are different.
I kind of got them mixed up. So which one is the one that goes the opposite?
Oh, yeah, that's what I was gonna
The one that goes opposite is the when we change x into 1/2 x.
Yeah.
1/2 x is not this, but is this. We multiply by 2. So when we change x into 3x, it's not this, but we divide by 1/3. So only when we change x. Yes. Is that good enough, Alex? Let me know.